So very simple question, direct. It is related to the enthalpy change and entropy change, but coupled with various other chapters. Very important question. The first one, they indicate that P, physics option. So in case of physics option, the change in free enthalpy is negative because during physics option, surface energy decreases and it appears as heat. Therefore, delta H is negative. And what about delta S? During adsorption, the number of free molecules decreases. Therefore, change in entropy of the system also decreases. So, this is negative. Next, we will go to Q. In Q, diamond is converted to graphite. Diamond to graphite. Graphite is thermodynamically more stable. This reaction delta H is negative. And if you compare the structure, diamond has 3-dimensional structure. Graphite is also has 3-dimensional structure. But if you compare the structure, graphite has something looser structure. This has 3-dimensional network, whereas the covalent bonds are strong. Therefore, delta S also here becomes positive. Entropy of the graphite is more. Therefore, change in entropy is positive. So, we will go to next R. So, in R, denaturation of protein is asked. Denaturation of proteins. So, during denaturation, we are going to heat it. Therefore, delta H is positive. What about delta S? So, during denaturation, the structure will be disrupted. Secondary, tertiary structures will be disrupted. Therefore, the change in entropy is also positive. The entropy change is positive. So, we will move on to the last, that is propene to cyclopropane. Propene to cyclopropane. So, in cyclopropane, there is an angle strain. Due to angle strain, propene is thermodynamically more stable. Propene is thermodynamically more stable. Therefore, this conversion is delta H is positive. And also delta S is negative. Why delta S is negative? Because in case of propene, it is an open chain structure. Therefore, there is more degrees of freedom. Whereas in case of cyclopropane, lesser degrees of freedom. Therefore, change in entropy is negative. So, I repeat the options: delta H negative and delta S negative, delta H negative, delta S positive, delta H positive, delta S positive, delta H positive and delta S negative. That is option C. Option C. Okay.
Hello students. So I hope the paper of JEE Advanced went well for everybody. So we shall discuss the answers and solutions. Okay. So I'll start with question number 14 from paper 1. This is a classic question which will be asked in the JEE Advanced. It is related to chemical bonding, the shapes of the molecules. So they have given such a set of molecules here. They are asking you the shapes of molecules. It's a column matching type question. So let's discuss this. So the first compound they have given is SOCl2. So what is the shape of this molecule? Well, there is a shortcut method which you might be knowing, right, to solve this question. So the shortcut is we'll count the number of bond pairs and lone pairs on the central atom, which is sulfur here, right? So sulfur has how many valence electrons? 6, and therefore it is attached to here oxygen and chlorine. So we should check how So here, this is monovalent atom. The shortcut method is to take the number of valence electrons of the central atom plus number of monovalent atoms attached to it. If there is any charge, we'll add that or subtract that. Since this is a neutral molecule, there is no need. And divide it by 2. So this one will give me 4. Out of 4, if you see, out of 4, the number which we get, if you see, it is attached to 3 atoms, which concludes alone 3 bond pairs are present and 1 lone pair is present. Now if you see the VSCPR table, which shape justifies 3 bond pairs and 1 lone pair? That is trigonal pyramidal. Trigonal pyramid. So right, this is the first molecule which is given. Next, I can also draw the molecule for you. Sulfur will bond, double bond with oxygen, 1 chlorine and 1 chlorine with 1 lone pair. Sulfur has 6 valence electrons, 4 bonds and 1 lone pair. Therefore, the shape is trigonal pyramidal. Right. Now, what is the second molecule? Second is HCOF4. Now, this one is inert gas. It has how many valence electrons? 8. Why am I taking 8? Because I am taking the central atom here. The central atom is xenon, which has 8 valence electrons. Plus, it is attached to 4 monovalent atoms. So, 8 plus 4 divided by 2. This one will give me 6. Out of 6, if you clearly see here, 5 are bond pairs and 1 is lone pair. So, 5 bond pairs and 1 lone pair. What is the shape if I take 5 bond pairs and 1 lone pair? Yes? Which one is the 5 bond pairs and 1 lone pair? Square pyramidal, isn't it? Square pyramidal. So, xenon will be the central atom, 4 fluorine atoms, and 1 double bond and 1 lone pair. This is the structure of HCOF4. Right? Now, let's look at the third one. Third one is ClF3. ClF3. Chlorine being the central atom. Now, if you see, how do I identify a central atom? As per the rule, the least electronegative atom is a central atom. Yeah, there are exceptions though, like hydrogen cannot be a central atom. Right? So, chlorine 7 plus 3 divided by 2. This one will give me 5. Out of 5, if you clearly see, chlorine is attached to 3 bonds, 3 fluorines. So, therefore, 3 bond pairs and 2 lone pairs. 3 bond pairs and lone pair, 2 lone pairs, we will have in T shape. So, Cl, this is F, yes, and 2 lone pairs. So, this is a T-shaped molecule. So, these are the 3 structures. We have some more examples. Okay, let's look at the next example, which is ClF5. The fourth example is ClF5. Yeah, chlorine has how many valence electrons? Just now we have seen chlorine has 7 valence electrons plus 5 divided by 2. This one will give me how much? 6. Right, out of 6, 5 bond pairs are there and 1 lone pair is there. 5 bond pairs, 1 lone pair. Now 5 bond pairs, 1 lone pair means, just now we discussed in the second example, which is square by square pyramidal. Square pyramidal. Okay, now let's look at the fifth example. HCF5 plus. Xc means xenon has 8 valence electron, fluorine has 5, so plus 5 minus 1 divided by 2.
You have to be very
Yeah? Is it fine? Okay, hope I'm audible. Yes? This is fine, sir. Okay, so 8 plus 5 minus 1 by 2. Again, what do I get here? 6. Out of 6, 5 bond pairs, 1 lone pair. 5 bond pair, 1 lone pair, which means Again same thing, square, pyramidal. Correct? Okay. Next example. SO3 2 minus. Well, sulfur this is, therefore 6 valence electrons. There is no monovalent atom attached to sulfur, right? Oxygens are not monovalent, so I will not add this, but we have a charge over here -2. When there is a -2, I will be adding +2 divided by 2, which gives me 4. Out of 4, 3 bond pairs are there and 1 lone pair. 3 bond pairs, 1 lone pair indicates trigonal pyramidal. Yes, okay. So same here. S double bond O, single bond O, single bond O, and 1 lone pair. This is the structure, right? And XeF4, we have drawn the symbol of 1, F, 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 F. This is square, and 1 more F. So 1 lone pair. This is square pyramidal, isn't it? This one will also be similar to this. Okay? Fine. So next is XeF3 plus. XeF3 plus. 8 valence electrons plus 3 minus 1 divided by 2. So how much will this be? This will be 5. Out of 5 I have 3 bond pairs and 1 lone pair. 3 bond pairs, 1 lone pair. I'm sorry, 2 lone pairs. 3 bond pairs and 2 lone pairs is T shape. Okay. And we are left with the last one. The last one is SF4. SF4. Look at this. Sulfur, 6 valence electrons. Right? How many monovalent atoms it is attached to? 4. So 6 plus 4 divided by 2 will give me 5. Out of 5, sulfur is attached to 4 atoms. Right? Since sulfur is attached to 4 atoms, you have 4 bond pairs and 1 lone pair. 4 bond pairs, 1 lone pair. Now sulfur. So I'll just draw the structure. This are 4 bond pairs and this is 1 lone pair. How does it look like? This is called as seesaw shape. Seesaw shape. Okay, so we discussed, these are the molecules which are given in the question. We discussed all the molecules. Now the question says, list 1, you can here see the question. List 1 has 4 options: seesaw, T-shape, trigonal pyramidal and square pyramidal. And list 2 has how many of these have the particular shape, right? So if you just look at all the shapes and match, we will get option A. Because we have one seesaw, right? Okay. Fine. We have one seesaw, then 2 T-shaped molecules. We came across 2 T-shaped molecules, which we just discussed. Then trigonal planar, we have come across 0. We haven't got any trigonal planar structure, so 0. Whereas square pyramidal, how many we got? We got almost 3 structures of square pyramidal. Hence, the answer for this question will be option A. So I just hope everybody has got this right. Thank you.
Okay, so we'll see the solution of the question number 15 from paper 1. So the question says that we have a list 1 wherein we have certain compounds, and in list 2 there are the products, and the reaction here given is ozonolysis and presence of aqueous NaOH. So we are very sure that here only 2 reactions take place. One is ozonolysis and another one is aldol condensation. So we'll see what are the products formed. So basically what ozonolysis will happen, ozonolysis will do is, so have this compound. So ozonolysis will basically break the double bond, and across the double bond we will get double bond oxygen. That is what ozonolysis will do. So after ozonolysis we will get this product. I am going to break this double bond and we are getting double bond O over here. Okay, this is what we get. Now this will undergo aldol condensation. So aldol condensation, we have to see in which case more stable enolate can be formed. So in this case, when this undergoes a aldol condensation, we will get a product wherein one side we will get a 5-membered ring and another side we will get a 7-membered ring. Okay, so this corresponds to 2. So our answer for P will be 2. So this is formed wherever more stable enolate ion is formed. So enolate is formed over here. Therefore we get this product. Now let's check about Q. So Q, one side we have a 7-membered ring and other side we have a 5-membered ring. So first thing is that it is undergoing a ozonolysis. Again same thing, I need to break the double bond over here and add oxygen. So I am going to get this. Okay, now this is undergoing a aldol condensation. So more stable enolate ion is formed over here. So in this case what I am going to get is, I will get 2 6-membered ring. So this corresponds to 1. So Q corresponds to 1. So P corresponds to 2 and Q corresponds to 1. Now let's check R. So again this is undergoing a ozonolysis. So initial product is this is what we get, and this undergoing the aldol condensation, again we get a 2 6-membered ring. So this corresponds to 5. So we can check the option. So R corresponds to 5. Now we have S remaining. So S, we have 2 6-membered rings. So on ozonolysis, we get this. And next, this on aldol condensation. Now this is symmetrical, so it can happen anywhere. So what we get on aldol condensation is this product. Okay. So this is our answer. That is option. P corresponds to Q, P corresponds to 2, Q corresponds to 1, R corresponds to 5 and S corresponds to 3. That is option C is the answer. So hello students, we'll see question number from paper 1, we'll see question number 16. So it is match the following question. So let's see what is given. P is, we have a NO2 electron withdrawing group and we have a Br, and here we have a oxide. Here we have a oxide. Okay, so and the reagent given is aqueous NaOH. We can say that here in the here we have a electron withdrawing group and we have a kind of quite strong base as well. So here basically substitution reaction can take place, and along with that dehydration can take place. So this part will get converted into C triple bond N, and this part will get this part will be as it is, there is no change. Here we have a Br which will undergo substitution reaction and Br will be converted into OH. Therefore P corresponds to 1. Next let's check a Q. Q, what do we have is, we have a same thing but same compound we have, but the reagent given over here is different. Okay, this is what we have, and we have a anhydride and we have a weak base over here. Na2CO3 is a weak base, so it is not possible for substitution reaction to occur here. So the only thing that takes place over here is dehydration, that is oxime will be converted into nitrile, rest of the things will remain as it is. So Br will remain as it is, and this will be C triple bond N, and this corresponds to 2. So let's write here P corresponds to 1 and Q corresponds to 2. Okay, even though P and Q are the same compounds, here this will undergo substitution because we have a NaOH over here, but this will not undergo substitution because we have a Na2CO3 which is a weak base. Now let's check R. So R, what do we have is similar compound only, but we have 1 methyl extra. So we have 1 methyl extra over here. Other than that, the compound is similar. Okay, and the reagent given over here is aqueous NaOH. Now in presence of aqueous NaOH, when Br and OH are almost close to each other, what will happen is, whatever this OH is there, it will exist as a O minus. Since it will exist as a O minus, the Br will leave and go, and here cyclization takes place. So our answer will be cyclization. Br will go, proton will go, it will exist as a O minus. So cyclization takes place, this will be our answer, and this corresponds to 4. So R corresponds to 4. Like this we have only option B. So option B is our answer. But we can see what will happen in case of a S as well. So here the reaction is simple. Here the reagent given is aqueous Na2CO3. So here simple reaction will take place, that is hydrolysis. So the bond will break over here, OH here and H here. So what I will get here is this one. OH. So this will be our answer. This corresponds to 5. So S corresponds to 5. So that will be option D. Thank you.